All right, so next we talked about adding and subtracting polynomials. And remember that basically it just comes down to combining like terms. And remember that a like term has the same variable expression. So for example, number 58, n cubed is a like term with n cubed, but n to the fourth is not a like term, right? That's its own term. And n squared is its own term, right? And then constants can go together, so we can add 9, or actually subtract in this case, right? 9 minus 5. So like terms are terms that have the same variable expression, so the same variables and the same exponent included in that term. And remember, by the way, a term in terms of monomials, and this is one thing that we don't see in the review, is we talked about, okay, how do we classify polynomials by degree, by number of terms, right? Remember, the number of terms is, if we just count the terms, like 51, this would be a binomial, right? Because there's 2 terms. So remember, a term is anything that you're multiplying together, or anything that has a variable expression that has a positive exponent, right? Or we should say not a negative exponent. All right, so this would be a trinomial, right? This by itself would be a monomial, right? 3w would be a monomial by itself. So we have monomial, binomial, trinomial, and then anything more than that is just a polynomial with 4 terms, or a polynomial with 5 terms, or a polynomial with 10 terms. And so there's, not necessarily a name that's commonly used for anything above a trinomial. Okay, so that's by number of terms. Then we can classify polynomials by degree, right? So by degree is by the highest exponent with that one of those variables have, right? So this polynomial here would be degree 4. So it'd be a degree 4, a 4th degree trinomial, right? So it's degree 4 by the highest exponent, and it's a trinomial by the number of terms. Okay. Let's see. So here we'd have a 2nd degree trinomial, right? Here we'd have a 1st degree binomial, right? If we just have a constant by itself, like 10, that would be a 0th degree, right? It would be degree 0 because we have an invisible x to the 0 there, right? Okay. All right, so if you see a variable with no exponent, that's a 1st degree, if that's your highest exponent. If you see a constant with no variable, then it's a 0 degree polynomial. All right, so let me get some of this stuff out of the way. So yeah, in terms of adding and subtracting, remember that adding, we're just combining like terms. You can really just drop the parentheses if you want. So 1 like 52, if you wanted to, you could just drop the parentheses and just rewrite this. You don't have to, but you could rewrite it as 1 minus 3y plus 4y minus 6. And if you wanted to, you can actually group your like terms together. So this pink is work you don't have to do, but if it helps you, you're welcome to do it. Notice how I'm keeping the signs with each of the numbers, right? So the negative goes with the 6, the negative goes with the 3y, positive goes with the 4y, okay? So then we're combining like terms. So we have, I'm going to do the y's first. Negative 3y plus 4y, that equals positive 1y, right? I don't have to put the 1 in front because it's implied there. And then I have 1 minus 6, which is negative 5. So that's the answer, okay? So once again, just combining like terms. Now, sometimes we subtract, right? Like 54. Here we're subtracting, right? And so one thing you can do is you can just, if you want to write them without parentheses, you could drop the parentheses, but you have to change all the signs, okay? So the sign of x squared, the sign of 7x, the sign of 8. Whenever you have a negative out front, that changes the signs of everything inside, right? Because we're basically distributing negative 1. So when you multiply something by negative 1, the sign changes. And so this first polynomial, I can just rewrite because there's nothing in front of the parentheses, right? So I can just drop the parentheses and rewrite it 3 minus 5x minus x squared. Okay, but for the second set of parentheses, I'm going to rewrite all these terms, but I'm going to change the signs. So positive x squared is going to turn to negative x squared. Okay, negative 7x is going to turn to positive 7x. And positive 8 is going to turn to negative 8. Okay, so if I want to regroup these by like terms, I can. This time I'm just going to keep it like this and combine them, but if that helps you, definitely do that. So I'm going to start with the x squareds. So negative x squared minus x squared, remember that's negative 1 minus 1, so I get negative 2x squared. When I combine 7x with negative 5x, I'm going to get positive 2x. And then 3 minus 8 is going to be negative 5. All right. So notice that when we add and subtract, the variables don't change, right? So like I still ended up with x squared. What changed were the coefficients, right? So it changed the coefficients of these variable expressions, but not the exponents, not the variables themselves, right? So when we add and subtract, we just change the coefficients. When we multiply, like like we've seen with exponents before. I don't have it on this page actually, but when we multiply, that's when the exponents change. Okay, when we multiply and divide. So let me do one more, number 58. So here are like terms, and by the way, going back to 54 just for a second, you can also do mental math here, and you could say negative x squared minus x squared and get negative 2x squared, and then you could say negative 5x minus negative 7x, so that would be negative 5x plus 7x, right? So that would be positive 2x, and then you could say 3 minus 8, and that would be negative 5. So you can do it mentally that way, but just be careful with your signs. That's definitely the number one mistake by students in my experience, is just sign errors, right? So make sure you avoid those. All right, so 58. So I want to show you 58 because here we have some that don't have like terms, right? Like we talked about this earlier, but n to the fourth doesn't have a like term. So then you're just going to bring it over. So it'll be negative n to the fourth, right? Because I can rewrite these and change all the signs, right? And then these I can rewrite and just keep the same signs because there's nothing in front of these parentheses. Okay, so when I combine like terms, negative n to the fourth doesn't have a like term, so it's just going to stay negative n to the fourth. N cubed does have a like term, right, with n cubed, so n cubed plus n cubed is 2n cubed. All right, and then negative n squared does not have a like term, so that's just going to come on over. Negative n squared. All right, and then 9 and negative 5 are like terms, so 9 minus 5 is 4. All right, so now we have a fourth degree polynomial with 4 terms, right? And that's our final answer. Okay, always double check to make sure you don't have any like terms. In this case, we don't, so it looks like we're done. So next in 4-4, we evaluated polynomials. So like number 60, it said find the value of the polynomial if x equals 4, right? So then what we do is wherever there was an x before, now we're going to put a 4, right? And then you just evaluate that, right? So PEMDAS, 4 squared first, right? Exponents first in this case. So we're going to get 16 minus 7 times 4. We actually could multiply those on that step. We'll do it on the next step. So 7 times 4, negative 7 times 4 is negative 28. And then now we can combine all these together. 16 minus 28 is negative 12, plus 4 is negative 8. All right. So now 62 is basically saying the same thing, right? If I say find q of negative 3, I'm basically saying find the value of the polynomial if x equals negative 3, right? So they mean the same thing. And remember, it doesn't mean q multiplied by negative 3. It means your input is negative 3, and you're plugging that into the function q, right? So this is function notation, and we'll continue to this will continue to come up as you go all the way through calculus and so forth. So anyway, so q of negative 3 is what we're trying to find. So once again, we set up our function, but instead of x, I'm just putting parentheses, and then I'm going to put this value, negative 3, inside the parentheses. And then we'll just evaluate it, okay? So this will be 9 plus 18 minus 8. So I squared this. Remember, a negative times a negative is a positive. So since the negative is inside the parentheses, that's going to make positive 9. So don't write it like this, okay? If you plug this in your calculator, you're going to get negative 9, and that's not the same thing, right? So remember that we're squaring this whole value, right? We're squaring the input, and so we're going to get a positive in this case. All right, then I multiply negative 6 times negative 3. That's how I got the 18. And now we just combine all those together. So it's going to be 19.